Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 11 is on the screen. Once again, the first two is to simplify expressions. The third one is to solve. Let's see how you do with that. Copy and... All right, here we go. Number one. What'd you get for number one? Anthony. What'd you get for number one? Negative 4x squared minus what? 8. 4. Oh, frozen. Let it go. Hands, have you got that? Looks about right. And once again, go one term at a time. Identify 0 pairs, and so on and so forth. Number two. What? Yes. The 8. Oh, you told me plus 8? Plus 8? Hands, have you got plus 8? All right. Let's double check just to make sure. Negative 9x squared and positive 5x squared is negative 4x squared. Okay. Bless you. We got 7m. Then we got negative 2 and negative 5. That's negative 7. These are a 0 pair. Yes. And last but not least, 10 minus 2, that is 8. Okay. Next, number 2. Tell your neighbor what to do for that one, so like that we can pass it to someone. What do we do for that one? Bless you. All right, pass someone. Anthony, what do we do? Let's do the negative 3. That's negative 3x plus 15. And what else? And then the x, we get negative 2x squared plus 6x. So far, so good, yes? Then what do I do? Positive 3x. Negative 2x squared goes in the front. Plus 15. Hands if you got that. That is correct. And last but not least, tell your neighbor how to get that one solved, please. So like that we can pass it to someone. All right, pass someone. Add 5 to all sides. So we end up with negative 20 less than 4x less than 12. Continue. Divide by 4 all sides. We end up with negative 5 less than x less than 3. Hands if you got that. Yeah, we got it. All right, copy the agenda for today. Warm-up number 11, we're done. Today we're moving on to polynomials. Let's go. Your favorites, yes? Remember when you were introduced to polynomials, yeah? And tonight's home play is the play sheet. It's only 12 problems only. And from this point forward, guys, polynomials are your BFFs. You're going to be walking down the street, going to Donut Avenue to get your iced tea or whatever it is, your Takis, and all of a sudden in the alley you hear someone, you turn, polynomials, there they are. Oh yeah, they're not leaving. They're not leaving you anymore. So yeah, the whole year we're going to be working with polynomials. I just want to make sure I cover that today, set it as a foundation. It's a review / intro to what's coming up tomorrow and the rest of the week, maybe into next week. All right? We good? All right, so copy the code for your home play for tonight. We got D9IV6. 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 All right. So tonight you're going to classify polynomials. It's only 12 problems, and like I said, you need that code so you can get those problems from the Nearpod slide. Yes, it's only 12 of them. All right. So here we go. Let's get started. Our objective for today, I can classify polynomials. I can classify polynomials. Set up a Cornell note. You do need a Ferrier model, one of those. I'll give you some time for that. Also, you need to get something signed for me, right? Is that correct? All right, so I'm going to open that assignment, and I'm going to leave it open till 3:25. You need to get your screenshot grade signed. Yes? Yes, that's cute. All right. Did they give you a Happy Meal or stuff? Yeah? Okay, good. Very good. It started cooling off, right? It's cold. I was like, in the morning, I was like, nice. It was 70-some degrees. I was like, what? That's good. All right, so I can classify polynomials. Tell you never the main concept for today. What is the main idea for today? What's the main idea? What goes in the center of your Ferrier model? Brandon, Felix. What goes in the Ferrier model? Yes, polynomials is our main idea. That is correct. And what are we going to do today? We're going to classify them, which means I want you to make sure you understand what you're looking at and you know the name of them. Okay? So here we go. Polynomials. What are they? Monomials, or sum or difference of monomials. Examples: 2x squared negative 3x to the fourth plus 2x squared minus 3x plus 2. And here are none examples. Copy these hashtags for the sake of time. I'll give you some time. Copy and go. Here we go. Look up to the screen. I'm going to go part by part once again just to make sure we got it. You can finish copying as we go along. According to the definition, polynomials are monomials or sum or difference of monomials. Well, first let's find out what monomials are. Monomials are expressions of one term. Let me repeat that again. Monomials are expressions of what? One term, which means only one part. For example, the first monomial that I can think of is 2 or x squared. 2 is only one part. X squared is only one part. That's known as a monomial. However, this one and this one is the sum or difference of monomials. So let's see. This is a monomial, then we add 2, so that makes it 2 monomials. Is that correct? And they're being added. That becomes a polynomial. Here goes another. Same thing, monomial, monomial, monomial. What's happening between addition and subtraction? So these are also polynomials. Now, for you to remember what polynomials are, look up. Let's break this term up. The word poly means many. Monomial means term or part. So that means polynomials have what? Many parts. That's what polynomials are. Okay? So, let's continue. So looking at these, what do you guys notice that all these have that these don't have? Tell your neighbor, please. What do all these have that these don't have? Looks like Trinity's got it. Yeah, Jaden's got it. All right, Jaden, what do these have that these don't have? Equal sign. So these are equations. So that means if these are not equations, what are these called, everyone? Expressions. That's why your first hashtag was what? Hashtag expressions only. Yes? All right. So, and then what else? Various parts or various terms. Okay? All right, I think we got it. Yes, from 1 to 5. Is it coming back for some of you? They're like, oh yes, Mr. Q, this was my favorite. All right, good. All right, next. Look up to the screen. Here goes some terms that you need to know. Just make sure you pay attention. You don't need to copy those. First term. Terms means the number of parts in an expression. How can we tell the number of terms? Well, you need to find out where it starts, and whenever you see a plus or a minus after that, that's a part of an expression. Like terms are two of them that are the same kind. So look at this one. Turn to your neighbor, let them know how many parts does this one have. How many parts does that one have? Everyone, how many parts? 3. And here it goes. I'm going to start from here. I start 1, and I stop wherever I see a plus or a minus. So there's 1 part. Here goes another 2 parts, and then the last one is right there, 3 parts. Okay. So far, so good. Which are the like terms? So you never the like terms. What are the like terms? Yeah, the 4x and the 3x. The 2 is known as a constant. Next, coefficient. Look at these. Coefficient is the number that multiplies a variable. Which numbers are multiplying the variable, everyone? The 4 and the -3. So the 4 and the -3. Those are coefficients. Okay. And last but not least, whenever I give you an expression that doesn't have a coefficient, you're going to write, let me repeat that again, you're going to write the number what? 1. Are we there? Okay. So with that said, look up to the screen, don't copy this. Parts of the expression. Tell your neighbor how many terms do we have on that expression. How many terms? Share with your neighbor, please. How many terms? Miroslava, how many terms? 4. That is correct. Let me write that in here. 4 terms. Let's see. 1, 2, 3, 4. Okay. Which are the like terms? Tell your neighbor, and then we're going to pass it to someone. Tell your neighbor what we got. Which ones are the like terms? Guys, someone, Miroslava? 6x squared, and what else? And x squared. And then we said if it doesn't have a coefficient, you write a what? A 1. Hands, have you got that so far? Yes? All right. Which is the constant? Tell your neighbor, please. Which is the constant? Pass someone. 4. That is correct. This number that does not have a variable. And last but not least, careful with this one. Which are my coefficients? Tell your neighbor, which are my coefficients? Which are my coefficients? All right. Pass someone. Trinity, coefficients. -5, yes, because the -5 is multiplying the variable, comma, what other? The 6, yes, because that's multiplying that one. And what other? She said 1? 1? Yes, that is correct. An invisible 1 that's multiplying the x squared. From 1 to 5, how comfortable are you with that so far? All right. So copy this next one, please. Example Q. Example Q. And it reads, parts of the expression, copy the polynomial x squared plus 10x minus 3 minus 8x, and answer all 4 parts. I'll give you some time for that. Go. Once again, by the end of the day, I'll upload the video lesson in case you need to revisit some of the parts, because from this point forward, it's going to go a little faster. I'm just trying to get all the little pieces in place. Let's see, how many terms in this expression? Martin, what'd you get? 4. Hands, have you got that? That is correct. Like terms, pass someone. Martin. (10x) and (-8x). Hands, have you got that? Yeah, make a correction. If some of you wrote just 8x, be careful. Remember, from now on, make sure you attach that negative to the coefficient. Number 3, identify the constant. Pass someone, Danny. (-3). Hands, have you got that? That is correct. It's the number without any variable being multiplied. Okay? And last but not least, coefficients. What are my coefficients? Pass someone, please. 1, 10, and (-8). Hands, have you got that? That is correct. Here's a 1, the 10, and the (-8). All right? From 1 to 5, how comfortable are you up to right there? Yeah, we got this. Yes? Good review? Yes? All right. So let's start cranking it up a little bit. So write this down. Name of a polynomial. In parentheses, write classify. That's what it means. Name of a polynomial. Classify. All right? So since you have your colored pens, in red, write first name in red, last name in blue. A polynomial has 2 names, a first name and a last name. The first name is in red, the last name is in blue. First name and last name. Music. So here we go. Look up to the screen. Writing utensils down. Well, the first thing I do want to mention before we get into the names is I'm going to be talking about the degree. Don't write this down, just pay attention. The degree of a polynomial. When they ask for the degree of the polynomial, that means that I need to know what this means. What does that mean, Mr. Q? It means that it's the highest degree, in parentheses, sum of exponents of variables in one term. So the degree of the polynomial is the highest degree, which means it's the sum of the exponents of the variables in one term. So you're going to look at all the terms, the one with the highest degree, that's the degree of the polynomial. For example, look up to the screen. Let's say I gave you the polynomial 5 plus 8xy cubed plus 2x minus 6y squared. So pay attention. Here goes. I'm going to break down degrees first. Ready? You're just paying attention. You go to the first part and ask the question, does that have a variable? No. If it doesn't, this is 0 degree. Why, Mr. Q? Because we need to look at the sum of the exponents of the variables. Let me go to the next term. Look at this term. Does this one have variables? Yes, the x and the y. So what are the exponents? This one is a 1 and this one is a 3. So the degree is 1 plus 3, that is 4. Let me go to the next one. Look at this term. Does it have a variable? Yes. What is the exponent on the variable? 1. So what is the degree for that term? 1. And last but not least, let's go to the last part. Does it have a variable? Yes. What is the exponent on the variable? 2. So what is the degree? 2. So looking at all those degrees, 0, 4, 1, and 2, what is the highest? 4. So this polynomial is 4 degree. That polynomial is 4 degree. Why? Because the 4 is the highest. Are we there so far? Okay. So, on your paper, write this down. Example supercube. Write the question. What is the degree? Here we go. 3x squared minus 4 plus 5y plus 8x y squared minus 7x. Find me the degree only of that polynomial. What is it? 3. Hands if you got 3. Let's double check. That is correct. Does this one have a variable? Yes. What is the exponent? 2. So this is second degree. All right. Does this one have a variable? No. So what is the degree? 0. Does this one have a variable? Yes. What is the exponent? 1. So the degree is 1. Let's go to this one. Variables? Yes. Degree exponents 1 and 2. So that is 3. And last but not least, look at this one. Variable, yes. Exponent 1. This is first degree. So what is the highest of all of them? 3. That's why this is third degree. All right. So that is one of the names of the polynomial, by degree. And I'm going to give you the names in a little bit. So check this out. Look up to the screen. Don't copy this table. You actually have the Nearpod code where you can use that later on when you're doing your home play. Look at this table that I put together for you guys. All right. We have degrees. Here are the names according to the degree. And here's the last name according to the number of terms. So look up. Check this out. So the first name, according to the degree, if it doesn't have any variables and it's a 0 degree polynomial, it's called a constant. 1 degree, it's a linear. Second degree is a quadratic. Third is a cubic. 4 is a quartic. Fifth is a quintic. And anything after 5, you just do to the nth degree. 6th, 7th, 8th, 9th, and so on and so forth. That's the first name. The last name, according to the number of terms, how many parts it has. Do we know how to look at the parts? Yes. So 1 part is monomial, 2 parts is binomial, 3 parts is trinomial. Anything after that, you just say polynomial. So with that said, look up to the screen. I'm going to do one so you guys can see how to use this table. Here we go. I'm going to label this example Shazam cube. Just pay attention. Look up. Let's say I gave you the polynomial let me do 3x cubed minus 4y plus 7. First, we need a first name, degree. Look at it. Tell your neighbor the highest degree of that polynomial. What is the highest degree of that polynomial? Highest degree. Got it? Brandon, Felix. 3, that is correct. By looking at it, this degree is 3, this one is 1, this one is 0, so the highest degree is 3. So that means its first name, third degree, should be what? Cubic. Okay, so far so good. So the first name is cubic. Now we need a last name. How many parts do we have in this polynomial? How many parts? Everyone? 1, 2, 3. So 3 parts. What is that name? Trinomial. So therefore, this one would be a cubic trinomial. Cubic trinomial. Yes? All right. So copy this one, write the name of it, cubic trinomial. I'm going to give you another one for you to do by yourself. Example, Michael Jordan cube. Let's go. Here we go. Let's do 8x to the 5th minus 1. Give you some time for that one. Give me the name of that polynomial. Record. Dominic, name of that polynomial. That? Martin, help him out. Quintic binomial. Quintic binomial. Hands if you got that. That is correct. All right, we got this, yes? Dominic, we good? Yeah, stay off that Chromebook, please. All right, so with that said, that's easy. We got it. Mr. Q, but what if you give us stuff that it's not in order, like the ones you just gave us? So copy this. Example Q. Example Q. Actually, label this one 1Q. Example 1Q. It says, classify the polynomial 6x minus 7x to the 5th plus 4x squared plus 9. 6x minus 7x to the 5th plus 4x squared plus 9. Now, I wrote some steps here on the side. You can copy those later. I'm just going to be checking them off as we go along so you guys can see how to use those steps to find the classification, okay? So here we go. It says, classify the polynomial. Step 1, identify the degree of each term of the polynomial. So let's do that together. Here we go. Circle the first term. Tell your neighbor the degree of that term. 1. That is correct. The exponent of 1. Let's go to the next one. Degree of that one, everyone. 5. Degree of this one. 2. And the degree of this one. 0. Okay, write that in there, please. That's the first step. Because these are simple. They're going to start growing. And I just want to make sure that you got the process. So step 1 is done. Step 2, arrange the terms or the parts from greatest to least degree. Let's start with that part. So look at it. Which is the greatest degree? 5, so I'm going to write negative 7x to the 5th. Then 2, which is plus 4x squared. And then plus 6x. And at the end, plus 9. So step 2, arrange from greatest to least degree. But we're not done. Check this out. What I want you to do extra today is identify the leading coefficients. Do we know what the coefficients are? Yes. Once this is in highest to lowest degree, you check the first term and look at the number leading. That's multiplying the variable, and you label that LC, or leading coefficient, which is negative 7. Copy that so far. And last but not least, we need to give it a name according to what? Degree and number of terms. So look at it and tell your neighbor the name of that polynomial. What is the name of that polynomial? All right. What did we get? Kimberly, name of that polynomial. quintic polynomial. Hands, have you got that? That is correct. Highest degree was what? 5, so that degree is quintic. How many parts? It's got more than 3, so it's a polynomial. From 1 to 5, how comfortable are you with this? All right, you got it. Okay. Let's crank it up a little bit, yeah? Tweezy. Copy. Oh my goodness. Hold on. This one, label it example 1, Shazam Q. Three y minus 7x to the fourth y minus 8 plus 4x squared. Write it in standard form, which means step 1, step 2 from highest to lowest degree, and then give me a name for that. Go. All right, check with the neighbor, see what they got. Make sure it's from highest to lowest degree and the name of that polynomial. Name of that polynomial. All right, help us out, please. Noah, degree for this one. That term, oh, sorry. For the first term. 1, how about this term? That one? So if we write them in order, what did you write? Four x squared, 3y, minus 8. Hands, have you got that? All right. So tell your neighbor the leading coefficient, everyone. See what they got. No, pass someone. Jacob. -7. Hands, have you got that? That is correct. It's the very first number multiplying the variable. And now we need a name. Name. Pass someone, Jacob. Jaden. Quintic polynomial. Quintic polynomial. Hands, have you got that? That is correct. Once again, from highest to lowest degree, label this one also. This is known as standard. Standard form. Standard form. All right. So, from 1 to 5, how comfortable are you with this? You got this, yes? All right. Let's do another one. Copy this one. Example 2. 9b plus 5a squared b minus 3a squared. See if you can go a little bit faster now. Copy and go. All right. Let's see. Who went last? Pass someone. All right. Brandon Felix. Help me with the degrees for each term. Bam. And then you wrote these in order, so we write what? (3a squared), and that's a negative, yes? All right. And then 9b. Hands, have you got that? All right. We need a leading coefficient. Pass someone. Five? Yes, that is correct. And last but not least, name. Pass someone. Oh, okay. Cubic trinomial. Hands, have you got that? That is correct. Any questions as to the classification of polynomials? Are we starting slow? Yes. So tomorrow we're about to crank it up a little bit. So tonight's home play is that. So I'm going to stop the video right here. and I'm going to show you the home place so you can see where you're headed with this. All right? Video will be uploaded tonight. It was afternoon. Go to it if you need the extra support. Bye.